Hello. Today what we're going to do is solving radical equations. And first we're going to jot down, I think this is page 225 in your packet. Okay. So first I want to talk about the steps for solving a radical equation, and then we'll do a bunch of examples on this page. Okay. First thing you're going to do first of all, a radical equation is any equation where there's a radical somewhere in the equation and your variable is underneath that radical. Okay, so the first thing you're going to do is isolate the radical, um, or the expression with the radical in it. Isolate that radical, which means get it by itself. Now, if you have multiple radicals in an equation, you have to do these one by one. So you'll isolate one of the radicals. So isolate the radical, or one of the radicals on one side of the equation. Isolate the radical or one of the radicals on one side of the equation. Next thing you're going to do is get rid of the radical. So if you've isolated a square root, you're going to square both sides. If you've isolated a cube root, you're going to cube root both sides. Square both sides or cube both sides, or if it's a fourth root, you're going to raise both sides to the fourth. Both sides of the equation to eliminate the radical. Okay, so you're going to square or cube, etc., both sides of the equation to eliminate the radical. Next thing, you're going to solve the equation. After squaring or cubing, for whatever your variable is. So for x, or whatever your variable is called. And then the next step is important. You're going to check your answers. If you have a step in the equation where you've squared both sides, or raised both sides to the fourth, or raised both sides to any even power, okay, you have to check your answers, because sometimes we create extraneous solutions. So you're going to check your answers into the original equation. For extraneous solutions. Okay, so check your answer or answers into the original equation for extraneous solutions. Extraneous solutions are values that you get for your variable or for x that seem to work, but when you plug them back into your equation, they don't actually work. Okay, so we'll talk about why that might happen when we get an example. Actually, I'll talk about it now. If I've got an equation, a simple equation, something like x plus 3 equals 0, right? Now I know that x is equal to negative 3. Boom, I'm done. Okay. But what if I had a step in this equation where I squared both sides of the equation? Okay. Let's say at this step, if we were to square both sides of the equation, then you get x squared equals 9. I know you're thinking you would never do that in this step, but sometimes you have to do it in a different step. My point is that squaring both sides of this equation actually creates a solution that doesn't actually work. If x squared equals 9, well, to solve this equation, if you hadn't seen anything that came before it, solving this equation, x could be 3 or negative 3. Now let's go back to our original equation. Does 3 work? Positive 3 doesn't work. Negative 3 does work. This step where we squared both sides created a solution that actually doesn't work. Okay, so we would have to check, does 3 work? Check your solution of x equals 3. Plug it into your original equation. 3 plus 3 equals 0. 6 equals 0. You'd be like, okay, that doesn't work. Wah, wah. And we would have to get rid of that solution. Okay, so let's go to some examples. Our first example. We want to isolate the radical. You could square both sides at this step, but we're going to divide by 2. We're just going to get the radical by itself. We get square root of x plus 5 equals 4. At this step, we have to square both sides. Again, there's that step where we're squaring both sides. This is the step that it's dangerous. We might create solutions that don't actually work. Okay? Squaring a square root, the radical goes away. You get x plus 5 equals 16. Subtract 5, you get x equals 11. Okay? Now, check your solution of x equals 11. And this is a step that you must show in your work. You might think, okay, I plugged it in, it works, fine. So this is my answer. But you have to show that you checked it, okay? So I want to see this step right here. Check x equals 11. So you're going to plug it in. 2 times the square root of 11 plus 5. I'm plugging in the 11 for x equals 8. That gives me 2 times the square root of 16 equals 8. Square root of 16 is 4, so 2 times 4 equals 8. 8 equals 8. So we know that 11 does in fact work. Check. I usually will put this in like a little bubble or a cloud, so showing that I checked my work. Okay. Let's go to the next one. Here you already have your radical by itself, but it's a cube root. So we're not going to square both sides. Squaring both sides doesn't get rid of cube root, but cubing both sides will. So this becomes 2x minus 9. Cubing a cube root will make that radical go away. You get 2x minus 9 equals 2 cubed, which is 8. Add 9 to both sides. 2x equals 17. Divide by 2, and x equals 17 over 2. Now, we don't actually have to test this one because cubing both sides of an equation is not going to create extraneous solutions. Because if you cube a negative, it doesn't become positive. Cubing a negative is still negative. So this doesn't cause a problem. Squaring a negative causes a problem. Squaring both sides when it's negative, because that makes this a positive, and then you lose the fact that this only works when x was negative, when this thing was a negative 3 instead of a positive 3. Okay? If you're not sure when to check your solutions, you can always take the 30 seconds to plug this in and check it and show that. Okay, let's go to the next one. Cube root of x plus 2 equals the cube root of x plus 3. Let's cube both sides. Notice there's 2 radicals here, but we already have one of the radicals by itself. Our first step is to isolate the radical, or one of the radicals. We have both sides have radicals, okay? So this one becomes x plus 2. This one becomes x plus 3. Subtract x from both sides, you get 2 equals 3, which is not true. So this would actually be no solution, or empty set. Or you could simply write no solution. Okay, you don't have to write all, just write as one of these 3 ways. Okay, let's go to the next one. Here's our radical. We're going to get it by itself. Subtract x from both sides. Square root of 24 minus 4x equals 3 minus x. Square both sides. That becomes 24 minus 4x. Make sure you FOIL this. Outers first, outers, inners last. So that becomes minus 6x plus x squared. Let's get all the x's on one side of the equation. I'm going to add 6x to both sides. So that gives me a 2x over here. Actually, I'm not going to do that. There's an x squared. And I want that x squared to be positive. So let's get everything on the right side of the equation. So I've got x squared. I have negative 6x. If I add 4x, that's minus 2x. I've got 9, subtract 24, and that gives me minus 15. Okay. Now here, I'm either going to use the quadratic formula to solve that, or I think this factors. So x minus 5x plus 3. So x would equal 5 or negative 3. Okay. Now I need to check both of those answers. Let's go, we're going to run out of some space. Let's use some space up here. So check x equals 5. So I've got 5 plus square root of 24 minus 4 times 5 equals 3. That's 5 plus square root of 24 minus 20, which is 4, equals 3. 5 plus 2 equals 3. And that's 7 equals 3, which is not correct. Wah, wah. So x equals 5 does not work. So that one gets crossed out. Okay. Sorry, that looks like I said equals 3x. I'll just say does not work. Let's put an x there. That one doesn't work. Okay, let's try the next one. X equals negative 3. We're going to plug this one. Give myself some space. So negative 3 plus square root of 24 minus 4 times negative 3 equals 3. So that's negative 3 plus, that's going to be 24 plus 12. So square root of 36 equals 3. Negative 3 plus 6 equals 3. 3 equals 3. And that one does work. So our only answer is x equals negative 3. Okay. Now, I know that this one, number 5, is going to take more space than that, so I apologize you don't have enough space. I'm going to do this on a separate page. Okay. So I've got square root of 4x plus 1 plus square root of 3x minus 2. Okay. Now, you might be thinking 4x plus 1, a common mistake when people first do these would be, okay, I've got the radicals over there. Why don't I get rid of these radicals by squaring both sides? Hopefully you see that that's going to cause a problem because you can't square both sides by simply squaring both of the terms. This is a binomial, so you would have to FOIL. You'd have to do first, outers, inners, lasts, and by the time you did all that, you'd have so many radicals and none of the radicals would have gone away. Actually, a couple of them will go away, but you're going to have some radicals. Actually, will they? Yeah, the outers and inners will not go away. Okay, the firsts and the lasts will go away, but the outers and inners will not, so that is not a good approach. Instead, like it says in step number 2, or step number 1, isolate the radical or one of the radicals. We need to do this one at a time. We can only get rid of one radical at a time. So let's isolate the first radical, 4x plus 1. On the other side, I've got 5 minus square root of 3x minus 2. Square both sides. Notice on this side, the radical is going to go away. This side, the radical is not going to go away. But at least we're only going to have one radical now instead of 2. Okay, so this becomes 4x plus 1. This, got to do first, outers, inners, last. Just for this one, I'm going to write it all out so I don't confuse you. So if you don't write it out, there's a lot that you're doing in your head. Okay, so we get 4x plus 1 equals firsts. 5 times 5 is 25. Outers, minus 25 minus 5 times rad 3x minus 2. And then the inners minus another 5 rad 3x minus 2. And then plus the final negative times a negative, the lasts. Negative times a negative gives you a positive. Rad 3x minus 2 times rad 3x minus 2 gives you 3x minus 2. Okay. So 4x plus 1 equals 20. Actually, let's combine these like terms. The 25 minus the 2 gives you 23. Then we've got the plus 3x. And then here we've got minus, these are like terms. So minus 10 rad 3x minus 2. Okay. And let's move all this over to the left side. So 4x minus 3x gives you x, and that's 1 minus 23 gives you minus 22 equals negative 10 rad 3x minus 2. Okay, now to isolate the radical, we could divide by the negative 10, but you know what I'm going to do? I'm just going to square both sides. This is not a binomial. if we square this side and square this side, the radical still goes away, because what we get is negative 10 squared, which is 100, then times this thing squared, which is going to be 3x minus 2. And this side, I'm going to FOIL that. That's going to be x squared minus 44x plus 22 squared, which is 484. Okay, so I've got x squared minus 44x plus 484 equals 300x minus 200. Let's get everything on the left side of the equation. So that's x squared minus 344x. Add that over here, so plus 684. And this is a little bit of a nightmare. These are big numbers, but that actually does factor. It's actually not that hard to factor, because you're looking for two numbers that multiply to 684 and add to negative 344. Okay, which in order to add to 344 and multiply to this, 342 times 2 gives you 684. So that's going to be x, they're going to be minus 2, and then x minus 342 equals 0. Okay, so your two answers are x equals 2 and x equals 342. Let's check our answers. Check x equals 2 in the original equation. Our original equation was this thing. So that's going to be square root of 4 times 2 plus 1 plus square root of 3 times 2 minus 2 equals 5. So that gives you square root of 8 plus 1, square root of 9 plus, that's 6 minus 2, square root of 4 equals 5. That gives you 3 plus 2 equals 5. And check, that works. 5 equals 5. So we know that x equals 2 does work. Let's check the other one. X equals 342. Check. X equals 342. Plugging in again to your original equation up here. So that's going to be, on focus, square root of 4 times 342 plus 1 plus square root 3 times 342 minus 2 equals 5. And we get, this is going to give you 4 times 342. It's going to be 1368 plus 1, square root of 1369 plus, so 3 times 342 minus 2. That's going to give us, this gives us 1026 minus 2, 1024. And square root of this is 37 plus square root of this is 32 equals 5. So we get 69 equals 5, and that does not work. Okay, so we've checked this one. So this one doesn't work. Our final answer is just x equals 2. Okay, sorry about the messy numbers there. Okay, let's go to number 6. And this one we can figure. Okay, this radical is already by itself. Square both sides. This one's more manageable, huh? 3x minus 5 equals, and squaring that, you're going to get x squared minus 2x plus 1. So let's get everything to the right side. I want my x squared to be positive. So x squared minus 5x plus 6. So 0 equals, that's going to give you x minus 2, x minus 3. So x equals 2 or x equals 3. Okay, let's check our answers. Check. X equals 2. So square root of 3 times 2 minus 5 equals square root of 2 minus 1. That's going to be 6 minus 5. Square root of 1 equals square root of 1. 1 equals 1. That one works. Okay, and let's check the other one. Check. X equals 3. Okay, so we get square root of 3 times 3. 9 minus 5 equals, oh, sorry, this side over here is not squared, but that's 2 minus 1. So this one still works. That was just 2 minus 1. 1 equals 1, squaring both sides. Okay. And this on the other side, we're going to get 3 minus 1, so 2. So square root of 4 equals 2. 2 equals 2. And check, that one works also. So don't make an assumption if one works, the other doesn't. And here's a case where they both actually work. All right. And that's all for now. Thank you all for watching. I will see you next time.